This lecture gives an intro to the Agile methodology using Scrum. The diagram on the left may look familiar to some of you if you've been doing software development for any amount of time. Frankly, it seems unfair to call it traditional at this point, since so much of the professional development world has adapted into a less rigid flow. This represents what we would call a waterfall model, also a traditional project management model. The idea is that by doing the due diligence up front, that costs would be further saved down the line. For instance, if we can determine before we write a line of code what the user interface will look like and how it will work best, then we can avoid having to redo it later in the process when we have to retrain the workforce or suffer the consequences of doing change management more than once.
For those of you who've been doing software for any amount of time, this seems old and stodgy. And by the way I'm telling you the story, you might feel like this approach is ripe with challenges and pitfalls. In reality, it's a sound way to think about taking on a project. For instance, if you were to build a house, it would be helpful, I would say even necessary, to survey the land, decide where the house might sit, before we call up the cement trucks to pour the footers and framers to start the building. Once we poured cement, the cost of changing the layout of the house, sitting on that foundation, is really high. Same thing with software development. While writing software doesn't have the physical limitations inherent in a construction project, it's still significantly more expensive to make changes further into the realization of the solution we get. That is, the cost of re-engineering a subsystem is much higher than developing a few Word documents, PowerPoints, and having a meeting to discuss the software features ahead of time. While the approach is logically sound, it assumes that we can be accurate in the early stages and extremely predictable in the follow-on steps. Even the best teams have challenges getting it right. Customers review designs and the final product on paper, think this meets the need. Theoretically, the engineers should be able to connect two different systems together easily, but in reality, they're just things that can't be accounted for. Maybe the technician has her hands full when some of the data needs to be entered, but the analysis and planning effort didn't witness the real-world business process and overlooked this aspect. It's highly likely that two subsystems should work together that don't, causing a major delay in the coding phase, which then pushes out the testing and development, or worse, requires a redesign of the system interfaces. Going backward in a waterfall model is expensive, time-consuming, and have major ripple effects on the outcome. Just to get a sense of the issue, the failure rate of large projects, that is, we're talking about projects costing $10 million or more, is just astonishing. In all, software projects have a high failure rate where only 64% of the projects meet their goals. On average, a large IT project runs 45% over budget, 7% over time, and delivers 56% less value than expected. This isn't always the fault of the project management approach, but usually it has to do with the longer a project goes on, the more the underlying business requirements change, or the project wasn't understood well enough at the beginning to have any chance of success.
Consider missions such as this one. Getting to Mars is insanely expensive, with just over $1 billion and 15 years of planning and design prior to deployment. The cost of failure in this case is so high, that is, what it would cost to build another rover and send it to Mars, that taking time to test out all the assumptions and get it precisely right the first time is of utmost importance.
We've already seen these challenges with the traditional methods, and we've more recently seen project managers and development teams have turned to different approaches in order to cope with these challenges. Rapid prototyping, where small pieces of the system are developed and tested individually to ensure viability. This not only ensures that the engineering design is solid, but it helps to identify weaknesses and failure points very early in the process. Spiraling models, where features are delivered incrementally. For instance, we might first develop a user interface which has no logic behind it. Buttons are present on the page, but they don't do anything when pressed. A follow-on release may then add page navigation, but no verification of input or business logic is applied. Each release adds a bit more functionality and expands the scope of the final solution incrementally. The spiraling approach allows us to engage end users very early in the process. Seeing a web page design on paper, versus being able to use it. Is a much different experience. Giving end users access to the partially built solutions early and often can have a tremendous help in prioritizing features, gaining the confidence for stakeholders, and influencing the direction of the project before expensive and time-consuming efforts are started. Also, testing and verifying the results as early as possible. Oftentimes, this comes with automating the tests so that as more and more functionality is added, we can verify that the later changes haven't affected the things that were working early on. In February 2001, 17 practitioners agreed to a common set of guidelines and principles to help give structure to the techniques they were employing, like these listed here. They called their new approach Agile, and while Agile principles are not the same as lean manufacturing principles, there is a bit of an echo. Lean manufacturing principles encourage continuous improvement through a process of identifying value, finding the sources of inefficiency, and pursuit of perfection. These 17 individuals then wrote a simple vision statement for themselves called the Agile Manifesto. There are really 4 key points in this vision. This group of forward thinkers took a few simple concepts and defined some guideposts for developing software. While companies like IBM, Microsoft, and Rational were working feverishly to reduce the potential for errors in software and reduce the time to go from design to solution, with products intended to develop code from architectural drawings, the Agile team took the approach that the interactions between developers and users, and developers of the front end and developers of the back end were to be more highly valued. This bleeds into our next point as well. If time spent showing the user how the software works, then maybe it's more intuitive and documentation isn't quite as important. Have you seen the manuals we used to create? Shelves of 4 and 5 inch binders of documentation on how to use SAP SQL Server, Windows NT, IBM, SPSS, for instance. Adult supervision, I like to call it. Funny things happen when you deliver software quickly. You can get feedback quickly. And if you're set up to be nimble, responsive to feedback, then you can make changes that reflect customer feedback rapidly. When this happens, customers see progress and feel heard. Dev teams don't spend hours on end perfecting systems that don't get used or don't work the way their customer intended. But in all, it was important to the writers to acknowledge that companies make money and do so by having accountability. The last point here addresses this, saying that the processes, tools, documentation, contracts, and plan have a place, but that given a choice, having working software that people want is of utmost importance. Rather than read this slide to you or share the implications of each point, I think it would be wise and a good exercise to pause the video at this point, read the items here, and reflect on them a bit. It's not necessarily important that you remember what number 3 and number 9 on the list are, or the exact wording of, say, number 7, but rather that you can paint a picture using these principles. Understanding the goal that the founders were after is much more important than memorizing the content. Because the understanding and considering these principles, the tools, techniques, ceremonies, artifacts make much more sense. Additionally, and this will bear repeating again and again, companies that claim to be Agile or practice Scrum will often not look like other companies touting the same philosophy. This is okay and to be expected. Much like there are different customs and different cultures, Many cultures share a similar moral code, and these principles represent a common code that can be implemented in many different ways, all in the pursuit of more predictable outcomes, more flexible project management, higher end user engagement, and better overall solutions. If you're to search the web for Agile Project Management, you're likely to come up with dozens of different representations of the process. Here's a few images you might see. What's common about the representation of all Agile projects is that they show some form of iteration, a process which repeats many times, each time executing the same phases, including requirements gathering or requirements refinement, design, implementation, release. Nearly every image will accentuate the repetitive nature and ongoing improvement cycle. Agile projects are done in iterations. Each iteration is meant to be a short project of sorts in its own. There's a bit of requirements gathering or refinement, some planning, execution, testing, and release. By breaking down a large project into these shorter duration, smaller scope stages, the likelihood of overall success goes up because we can fail fast or succeed fast. We can also adjust late in the process to changing conditions or new information. In a waterfall, a more traditional project management style, there's a steady hum of work from the beginning to the end, often gaining momentum near the end of the project when all is revealed and the customer either accepts the final product or requests changes. And of course, changes at that stage of the game are expensive and time-consuming. Further, as the project wanes on, deadlines are missed or developers and testers are run into the ground as they try to meet deadlines for months. Set months before. The scope wasn't nearly as clear or well designed. We'll talk more about this when we focus on how to manage a Scrum project or sprint. How Agile takes this and allows clarity to happen naturally as the project progresses. The Agile Project Management Framework, or APM for short, suggests the workflow looks something like this. Notice again how each stage includes some documentation accountability, but overall the goal is to try things and fail quickly. So I once had a colleague who told me that he was much more contemplative about his software delivery, taking time to plan his work, employing the measure twice, cut once rule. He would describe himself as ready, aim, fire, bullseye approach. I prefer to work much more in an agile approach, describing my technique as fire, 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 fire. Oh, hey, we hit something. This aligns well to the difference between a waterfall type project and an agile project. The goal in an agile project is to be consistently delivering working software so that customers have more timely and better input along the way. There'll be failures and misses, but because of the rapid cycles, these failures are caught early and working solutions happen more regularly. Both the engineers and developers delivering the solutions and the end user are able to more accurately prioritize the effort and define a better outcome. Once more, I would encourage you to spend time and reflect on the picture here and the definitions. They aren't going to be tested per se, but the idea they represent really help to make the purpose of the approach clearer. Think as well about the manifesto in relationship to these stages and how together they form a very clear philosophy for how to deliver software in a rapidly changing, technology-driven world. While we're at it, we might as well describe Scrum. I've used Scrum and Agile interchangeably throughout this talk, but it's not quite right to do so. Scrum is a software development approach that adheres to the Agile principles. There are other popular implementations, such as the disciplined Agile approach, XP, that's extreme programming, Kanban, and others. The next lecture will focus on the roles involved in the Scrum process and also deep dive on the Scrum lifecycle. For now, it's reasonable to interchange these terms, as Scrum is by far the most popular methodology for Agile. Finally, and we'll be coming back to this picture over and over again as we look at the Agile development lifecycle. This shows the general approach of an Agile project, showing the different roles, stages, and deliverables during a Scrum project. Projects begin with an analysis phase where the best possible representation of the system is discovered. Teams then take sets of requirements and define and develop solutions in a very short, fixed time period, usually 3 to 6 weeks. It's intended that features are defined to be small enough to be completed in these short time frames in order to keep the project moving forward and getting feedback from the end users. At the end of each iteration, stock is taken of the progress, requirements are updated and reprioritized, and the process starts all over again, with developers delivering on the next set of features or functionality. This rhythm can continue for a very long time, until the project is fully realized or the organizational priorities shift. Traditional software project management, also known as waterfall, expects work to flow from top to bottom in a linear fashion with significant cost incurred for moving backwards. This approach requires discipline and rigor to succeed, but also is essential when the risks of failure are high, and certainly when the impact of those failures are high. Agile project management, based on the principles written in the Agile Manifesto, use an iterative approach, breaking down the problem into shorter duration and smaller scope projects where the goal is to maximize end user participation and move toward perfection incrementally. Both approaches have value, though we've seen lots of companies adopt and adapt Agile techniques, even combine them when some discipline of the waterfall approach is required in order to build successful IT systems.